Good morning, dear students. I hope you all are doing great. So today we are going to discuss about the very important and interesting topic in chemistry, that is applications of radioactive isotopes. So we are studying this lesson through page 25 and 26 from our textbook. So today we will explore how special atoms called radioactive isotopes and they are used in amazing ways across medicine, industry and science. Get ready to discover their hidden parts. So, what are radioactive isotopes? Imagine atoms are building blocks and all atoms of an element usually have the same number of protons and electrons. We already have been discussed in the previous lessons as well that all the atoms of an element usually have the same number of protons and electrons, but they can have different number of neutrons. We call them isotopes. So let's talk about what are the radioactive isotopes. So radioactive isotopes are atoms of the same element. Radioactive isotopes are the atoms of same element but with different or usually higher number of neutrons. This makes them unstable. What does it mean by unstable? Unstable is a condition when they are not in the form of stability, they are not in balanced form. Radioactive isotopes are become stable. To become stable, radioactive isotopes release extra energy in the form of radiations. So, dear students, to become stable, radioactive isotopes release extra energy in the form of radiations. That's why we call them radioactive, because they release radiations, right? So, this process is called radioactive decay. Radioactive decay. Decay means the breakdown of something, the something splits into smaller units. It's the decay. So this phenomena is known as radioactive decay. Dear students, it's time to discuss about the applications of the radioactive isotopes in medical field. What are the applications means the uses of radioactive isotopes in the medical field. So there are numerous radioactive isotopes that are used in medical field, but we will discuss that are mentioned in our textbook, right? So doctors use radioactive isotopes to get clear picture of what's happening inside your body without needing surgery. Doctors use radioactive isotopes to get a clear picture of what's happening inside your body without needing surgery. So just for the sake of example, we will discuss about the radioactive isotope that is technetium 99. Technetium 99. This is one of the most common medical isotope. It's like a tiny invisible dye that doctors can track where it used. Tactinium is used to scan brain, heart, lungs, kidneys, and bones. It's injected into the body and travels to the specific organs. So let's see how the technetium 99 works. A special Dear students, kindly use the landscape mode for the better understanding and the better clarification, right? So let's talk about how the technetium works. A special camera detects the radiation emitted by technetium 99 as it moves through the body, creating detailed images of organs and blood flow. How it works? A special camera detects the radiations emitted by these radioactive isotopes as it moves through the body and creating a detailed images of organs and blood flow. This helps doctors to diagnose problems like broken bones, blood clots, or even tumors. So in this way, technetium is used in medical field, right? Dear students, it's time to discuss about the one major use or one major application of radioactive isotopes in unlocking history, or this process is also known as radiocarbon dating. Radiocarbon dating. So, radioactive isotopes can help us travel back in time. Radioactive isotopes can even help us travel back in time to discover the age of ancient artifacts and fossils, right? So, radioactive isotopes can even help us travel back in the time to discover the age of ancient artifacts and fossils. Let's start with the carbon 14. Let's start with the carbon 14. It's the isotope of carbon element. We know that carbon has three isotopes: carbon 12, carbon 13, and carbon 14. Let's discuss with carbon 14, right? So all the living things absorb carbon 14 from the atmosphere when they die, right? All the living things absorb carbon 14 from the atmosphere when they die. They stop absorbing it. When they die, they stop absorbing carbon 14, right? Carbon 14 decays over time. Carbon 14 decays with the passage of time. Once an organism dies, the carbon 14 inside it slowly begins to decay into nitrogen 14 at a known rate, right? Once an organism dies, the carbon 14 inside it slowly begins to decay into nitrogen 14 at a known rate. So, dear students, the main question comes at this point: how the scientists measure the age of any organism or any non-living thing by using the decay of carbon 14 over time. So let's see, listen it carefully. Scientists measure how much carbon 14 is left in an object like woods or bones or fossils. The less carbon 14 present, it means the older the object is, right? So scientists measure how much carbon 14 is left in an object like wood, bones, or fossils. The less carbon 14 means the older the object is. Dear students, let's see how the radioactive isotopes are used in industrial purposes, right? Beyond medicine and science, radioactive isotopes play a crucial role in making our infrastructures like roads, bridges, schools, buildings. So it plays a crucial role in making our infrastructure safer and finding valuable resources. So dear students, let's start with cobalt 60. It is used for checking flaws or mistakes in materials like metal and concrete, right? Cobalt 16 is used to detecting cracks. It is used to find the hidden cracks or weaknesses in pipes, bridges, and buildings and making them safe. So dear students, there are a number of radioactive isotopes that are used in finding resources and energy. Let's see. Oil exploration. Some isotopes help geologists find where oil and gas might be trapped underground. Okay, so let's talk about the nuclear power. Isotopes like uranium 235 that are also used in the synthesis or the formation of atomic warheads. So, isotopes like uranium 235 are the fuel for the nuclear power plants, generating electricity for homes and businesses. So, dear students, these are some of the major uses of radioactive isotopes in different industries, in the field of medicine, in the field of industry, in the field of power production. Time to test our knowledge. Think about what we covered today. So, we have two questions here, And the question one is, why does a radioactive isotope emit radiation? Second question is, give an example of radioactive isotope we discussed and how it is used to become stable. So I will collect the answers when we will meet in the physical class, right? So that's all for today. If you have any question or do you face any difficulty, please feel free to connect us. We are here for you. Thank you so much. I hope you enjoyed learning about the exciting applications of radioactive isotopes. Remember, science is all around us, helping to improve our lives in countless ways. So stay safe, stay happy. Allah Hafiz.